All right, we are going to be looking in this first little section about functions, and I'm sure it's a word that you've heard before. There's a fancy definition for function that is a little bit hard to understand, and so we're going to explore this definition in several different ways. But the fancy definition for a function is a special type of relation in which each element of the domain, which if you can't remember is your x values, is paired with exactly one and only one element of the range, which are your y values. So we're going to look at a couple of different ways that we can kind of explore this definition, so hopefully that you can understand it a little bit better. First of all, a relation, just so you know, is a set of ordered pairs. So in this particular example that we are going to look at, the relation would be the relation in this case would be the list of ordered pairs, okay? And so our relation is going to look like this. You're going to make one of those fancy little brackets, which I'm not so great at, and you're going to list your ordered pairs. These are the things that are in your relation. So it would be a -3, 1, a 1, 2, a 3, 3, a 0, -2, and a -4, 0. Those are all the things in our relation, and they come from these ordered pairs right here, okay? And I really should list them in order from left to right, just so you know. I didn't do that this time, but I really should. So I should really list this term first, and this term second, and this term third, and etc. Okay? Your domain then are just simply your x values. So in this case, your domain goes like this, and I'm going to list these in order from smallest to largest. So my smallest x value that I see is -4, and then I have a -3, and a 0, and a 1, and a 3. That would be my domain. My range are the y values. So the y value at this coordinate right here is 0. The y value at this coordinate right here is -2. And I'm going to list these in order from smallest to largest also. So the smallest y value that I see is -2, and then 0, and then 1, and then 2, and then 3. Okay? Y values are your up-down values. So now we're going to look at a couple of other relations here. And we're going to kind of use the definition that we have, and we're going to talk about whether these things are functions and some different ways to tell that, okay? So in this particular first example here on the far left, if we give the ordered pairs that are in our relation, it would go like this. -3, 1, 0, 2, and 2, -1. So this point is -3, 1, this point is 0, 2, this point is 2, -1. What I want you to notice is that every single one of these x values are different. All of my x values are different. So that's a key right there that it is going to be a function. If all of your x values are different, it will be a function. If you have repeated x values, so let's say I have another coordinate right here, that would be -3, 4. That would make it not a function. But if it was -3, 1, and it's just simply listed twice, then it would be a function. If all your x values are different, it's a function. If you have repeated x values, like right here, -3 and -3, and your y's repeat with them, it's still a function. If you have repeated x values with different y values, though, it's not a function, okay? Another way I can tell whether something is a function or not is by looking to see whether it passes the vertical line test. The vertical line test tells you that you can draw a vertical line anywhere along that graph, and as long as that vertical line only passes in one spot at a time, then you know it's a function. So if I drag this vertical line across, I'm only hitting one spot, one spot, one spot. Never do I hit more than one coordinate at a time, and so therefore it is a function, okay? So yes, this one is a function, and then we're going to come back to the one-to-one piece in just a minute. Okay, on to the next example. If we list our coordinates here from left to right, our relationship, or our relation, would go like this. -2, 1, 1, 2, and 3, 1. Okay, again, I have all different x values, so I can tell you it's a function. It also passes the vertical line test. If I draw a vertical line anywhere along this graph, I only cross in one spot or one spot or one spot, but never more than one. So this is a function. Okay, and then lastly, if I look at this relation on the far right, and I go from left to right, my relation would go -1, -2, 1, 2, and 1, -1. So I've just lifted the coordinates there from left to right. You can see that you've got a problem right here because I have two x values. Oops, not that one, sorry. Let's try that one more time. I have two x values that are the same, an x value of 1 here and an x value of 1 here. And the problem is they have different y's that go along with them. So when you have repeated x's, the same x with different y's, that's not okay. You can tell that graphically because, whoops, if I go over here and I draw my vertical line right here, you can see that my vertical line is passing through more than one coordinate at a time, which makes it not be a function. So this one is not a function. Okay, and then we're going to look at whether something is one-to-one or not. One-to-one means every y value has exactly one x value. And this means that it passes the horizontal line test. So what you need to know first of all is that it has to be a function first before it can be a one-to-one function. If it's not a function first, then we don't even worry about whether it's one-to-one. So we're going to go back and look at a couple of these other things over here, okay? So on this far left one, I already know it's a function, so I can decide whether it's one-to-one also. When I look at now my y values, every y value is different. So every x value is different, which makes it a function. Now every y value is different, which makes it one-to-one. The other thing that I can do is I can take this line and I can make it horizontal instead. Let me see if I can get that here. And I can see if it passes the horizontal line test, which means that if I draw a horizontal line and drag it anywhere across the graph, it can only hit in one spot, which happens here. So this one is a function, and it is also a one-to-one function. If I look at the next example, I know it's a function already because all of my x values were different. But now you can see that I have repeated y values here. Both of those coordinates have a y value of 1, and they have different x's that go along with them. So it was a function first because all of its x values were the same and it passed the vertical line test. But it's not a one-to-one function because I have repeated y values with different x values, and it does not pass the horizontal line test, which I'll show you here. If you draw your horizontal line right here, you can see that that line crosses more than one point at a time, which makes it not one-to-one. And then this last one, if I can decide if it's one-to-one or not, this really is just simply not applicable. If something is not a function first, it can't be a one-to-one function. So we aren't going to worry about that. So anytime it asks you in your homework to figure out if something's one-to-one, first of all, think about whether it's a function. If you know it's a function first, then decide if it's one-to-one. Okay? Here's some examples and some non-examples of one-to-one functions, and I think we've hit that already, so we're going to move on. Okay? Next, sometimes in your homework it's going to give you a function or a relation anyway, and you have to decide if it is a function and if it's one-to-one. So a couple of different things you can do. One thing you can do is you can make a table, okay, where you just simply pick some x values and figure out the y that goes with it. So I am going to pick an x value of 2, let's say. If I pick an x value of 2, then I have 2 times 2, which is 4, plus 3, which is 7. So if x is 2, y is 7. If x is 0, then I have 2 times 0, which is 0, plus 3, which is 3. If x is -1, let's say, I have 2 times -1, which is -2, plus 3, which is 1. And hopefully you can figure out that if you plot these, I have the point 2, 7 and 0, 3 and -1, 1. What you're getting if you plotted this function would just be a line. Hopefully you recognized that this was a line in y equals mx plus b form. And a line is going to look something like this. It might have positive slope, it might have negative slope, but it looks like this. Notice that every x value, every different x value has a different y value that goes with it. There are never going to be repeated x's with different y values. If you were to draw a vertical line anywhere on this graph, it would pass the vertical line test. So this is a function, and it also would pass the horizontal line test. Every y has a unique x, and so it is also, it's a function, and it's one-to-one. Okay, this next example, by the way, you can stick these into your calculators too if you want and get them solved for y in order to be able to stick them into your calculator. And so I am going to just erase that, or maybe I'm not going to erase that. Here's what I'm going to do. I'm going to pick some things here, and we're going to go from here, okay? Sometimes on this, it's easier to pick your y values instead of your x values. Most of you, your instinct is to pick an x value. So this is what I'm going to do. If I want x to be 9, then what I want you to think about is if x is 9, what does y have to be? What number squared gives you 9? Well, 3 squared gives you 9, and so does -3. So now we have a problem because I have the same x values, but I have different y values that go along with them. So an x value of 9 gives me 2 different y values, which makes it not a function. If y is 0, x is 0. Sometimes, like I said, it's easier to pick out y values than it is to pick out x values, okay? So here we go. If we were to plot these points, we would have 9, 3, and 9, -3, and 0, 0. And I know you probably can't tell this real carefully, but this is a sideways parabola. If you wanted to graph this on your graphing calculator, you would have to have this solved for y, just so you know. So if I take that equation and I solve it for y, I would have to take the square root of that. And when you take the square root of that, you need a plus or a minus in front of that, just so you know. So if you're wanting to use your calculator in y1, you would have to put positive square root of x. And in y2, you would have to put negative square root of x because your calculator won't do the plus or minus square root of x in front of it, just so you know. And so you'd need to put both of those equations in, and it would generate a graph that would look like this. Clearly, this does not pass the vertical line test, so this is not a function. And if it's not a function, then we don't even need to worry about whether it's one-to-one or not, because that part of it is not applicable. And then lastly, is this guy a function? And you're going to get problems that look like this on your homework. And just so you know, these lines right here are approaching the y-axis, but they never touch it. They get, the higher it gets closer and closer and closer and closer and closer to the y-axis, but it never touches it. What you need to know, and same thing here, it gets closer and closer and closer to the x-axis as it goes across, but it never touches it. You need to know there are lines there called asymptotes, which we will talk a lot about later, but this little section up here is not a vertical line, and this section over here is not a horizontal line. I know it might look like it, but it's not, okay? So this does pass the vertical line test. I know it doesn't look like it would pass the vertical line test right here because your eye leads you to believe that it's straight up and down, but it's not. It gets closer and closer to that y-axis. So this one is a function because it passes the vertical line test, and it's also a function because it passes the horizontal line test. There's also one-to-one, I should say. All right, then In your homework, you guys are going to be given a bunch of different equations, and you need to just kind of decide if it's a function or not. So first of all, you want to look for equations that are linear, that are in y equals mx plus b form. Obviously, you're going to have a number plugged in for m, and you're going to have a number plugged in for b, but those create a line, and we already talked about lines are functions, and they are also one-to-one. No matter what the line looks like, unless it's a horizontal or vertical line, then that's different, but those won't have equations in this form anyways, okay? Parabolas. The key to knowing whether you have a parabola equation is looking for something that has an x squared in it. Not an x squared and a y squared, but if it just has an x squared in it, it is going to be a parabola. And it might open up or down, just so you know. This one is opening up, it might open down, and we'll learn more about all of that later. But this is a function because it passes the vertical line test, but it is not a one-to-one function because it fails the horizontal line test. Okay? Then, if an equation has both an x squared and a y squared in it somewhere, no matter what else it looks like, the key thing is that it has an x squared and a y squared in it, it will make a circle, and we'll learn all about these functions later, more about them. For now, I just want you to know if it has an x squared and a y squared in it, it's a circle, which is not a function. And then, of course, this is not applicable because it's not a function. Okay? If it has an absolute value symbol in it, that's the key to having an absolute value function. Those are V-shaped functions. Okay? And V-shaped functions are a function, but they are not one-to-one. Sideways parabolas only have a y squared in them, not an x squared, a y squared. And those look like this, and they could open to the right or the left. It doesn't really matter, but those also are not a function, which means we don't even need to worry about whether they're one-to-one. And then lastly, if it has a square root of x in it, it will look something like this, which is a function, and it is also one-to-one. So in your homework, just kind of look for some of those patterns, and hopefully that will help you. Okay? So that should be the end of this video lesson.